Today we're going to be graphing logarithms. Our objective is that the students will be able to describe and graph a logarithmic function. So consider the following equations and solve for x. 2 to the x power is 4. Well, we know 2 squared is 4, so we know x equals 2. 2 to the x power equals 8. Well, we know 2 to the third is 8, so x would have to be 3. 2 to the x power equals 6. Well, I don't know what that is. That's not a whole number. It's got to be somewhere between 2 or 3. And this is why we need logarithms. Logarithms would help us find that decimal that we can raise 2 to that power and get 6. So if we have log base b of y equals x, what that means is b to the x power would equal y. Since logarithmic functions and exponential functions are inverses, we're basically just switching the x and y values. However, today we're going to mostly be using Desmos for our graphing, so we won't have to worry about that as much. So here is our standard form of a logarithm. It's a times log base b of x minus h plus k. So if we have the example log base 3 of x minus 2 plus 1, our a value would be 1 because we don't see anything out in front of our logarithm. Our base is 3, our h is 2, and our k is 1. So with our exponential functions, we had horizontal asymptotes. Since they're inverses, the inverse of horizontal would be vertical. So these are going to be vertical asymptotes, so we know they're going to be x equals. So let's look at the graph first. Y equals log So actually, instead of typing log, take that back, we are going to go to Functions, Miscellaneous, and click the button that says log with the little a there, because that'll give us the space to put the 3 in. Log base 3 of x minus 2 plus 1. So it looks like our asymptote is at x equals 2, because that's where it's getting closer and closer to. But if we zoom in a lot, you can see it doesn't actually touch. So it's going to be x equals 2. Well, where else did we see a 2? Oh, it was our h value. So 2 and 2. So your vertical asymptote for your logarithmic functions is going to be x equals and then your h value. To help us sketch the graph, I'm going to click Edit List and then Convert to Table. Those are all undefined because there's nothing on that part of the graph, so I'm just going to keep clicking Enter to see if I can get some numbers help me out. So this looks good. 3, 1, and 5, 2. 3, 1, 5, 2. Our asymptote is at 2. So our graph curves like this and then keeps going down. So for our domain, we start at 2 and go on forever. The 2 gets a parenthesis because the asymptote's there and it's not actually ever going to touch. And then our range, our graph goes down forever, and this side goes slowly up forever. So our range is negative infinity to infinity. let's see what happens when our base is a fraction this time. So a is still 1. This time our base is 1/2. H would be -3, and k would be -2. We know our vertical asymptote is going to be x equals, and then our h value, so -3. Let's look at our graph. So y equals, go back to function. Luckily, the whole time we have Desmos open, it'll stay on this miscellaneous tab. If you close Desmos or refresh it, it'll default to the trig tab. You'll still have to go back to the miscellaneous. So log a, 1. Nope. We might have to put it in parentheses. Hold on. There we go. Okay. Desmos is being difficult this morning. We'll do it as 0.5. That will solve our problem. Get rid of these extra parentheses I made. All right, x plus 3. What is going on? Desmos has a mind of its own this morning. X plus 3. There we go. -2. All right, so our asymptote is still at -3. So it's at -3 like we saw. So this time it curves down instead of curving up. Let's use our table. All right, that's got some nice points for us to use. -2, -2. -1, -3. -1, -4. Gonna draw on my asymptote so I don't cross over it. And it goes like that. So my domain, my graph starts at -3 and goes to the right forever. So -3 to infinity. Range, this is slowly going to go down forever. That's going up forever. So -infinity to infinity. And our final example. So this time we have an a value of 2. Our base is also 2. Our h value is -5, and k is 3. So our asymptote will be at x equals -5. You may have noticed a pattern. All of the ranges were -infinity to infinity. Well, on our exponentials, the domain was always -infinity to infinity, and since they're inverses, it swaps to the range this time. You may have also noticed a pattern with the domain. Our asymptote was at 2, h was 2, our domain started at 2. Our h was -3, our asymptote was at -3, our domain was at -3. So for this one, we know our domain is going to go from -5 to infinity. Now, if you don't remember that pattern, don't stress because you have Desmos to look at. So y equals, got a 2 in front this time, log a of 2 x plus 5, close the parentheses, plus 3. So our asymptote is at -5 like we thought it would be. And then it's hard to tell in here, but it is stretched out a little bit more because of the 2 in front. So let's use our table to get some points. Okay, -1, 7 helps a little bit. But let's see if we can get some more over here. If we keep pushing enter, it's going to change it to bigger numbers, and we actually want smaller numbers. So let's try -3. That one works. -3, 5. Let's see what -4 gives us. +3. And we know it curves like that. That's all for today. Fill in your summary, and I'll see you in class.